Hi students, this section is 3.4, solving equations with variables on both sides. So just a little definition here. It says linear equations do not always have one solution. An identity is an equation that is true for all values of the variable. Some linear equations you will notice when you're solving will have no solution. So that's just a pointer that I wanted to make note of to you. But let's just go into some examples here when we're solving equations with variables on both sides. So ultimately here what you want to do is you want to get the number with the variables on one side and the numbers that stand alone on the other. So when we look at example number 1, we have 6x plus 22 equals negative 3x plus 31. So what I can do here is I can subtract 22 from the left, but if I subtract 22 from the left, I have to subtract 22 to the right. So what I end up with here is 6x equals negative 3x, and then 31 minus 22 is going to give me 9, so that'll be a plus 9. I want to take this negative 3x and move it to the left. So I'm going to add 3x to the right, add 3x to the left. So what I get here is 9x equals 9. We're solving for x now because we got the x's on one side. So we're going to divide 9 to the left, divide 9 to the right, and get x equals 1. The next equation here, we have 64 minus 12w equals 6w. I want to get the w's on one side and the numbers by themselves on the other. So I'm going to add 12w on the left, and I'm going to add 12w on the right. So what I get is 64 equals 6w plus 12w is going to give me 18w. Again, I want to get w by itself, so I'm going to divide 18 to both sides. Now, 64 divided by 18 is not going to give me a whole number, but if you divide the numerator and denominator by 2, 64 divided by 2 is going to give me 32, and 18 divided by 2 gives me 9. So 32 over 9 is going to be my w, and that'll be my answer. Make sure you circle your answers when you're solving in your bookwork. The next example, example number 2, they want us to solve these equations below. Notice we have variables on both sides, but we also have parentheses on both sides. So when we're looking at A here, we can distribute this 9 to the B. We have 9b minus 4 minus 7b equals 5 parenthesis 3b minus 2. So as I was mentioning, you're going to distribute the 9 to each situation in the parentheses. So you have 9b minus 36 minus 7b equals 15b minus 2. I'm going to combine like terms on the left side. So 9b and negative 7b, that's going to become 2b minus 36 equals 15b minus 2. I'll get the b's on one side and I'll get the numbers by themselves on the other. So what I'm going to do here is I'm going to add 36 to both sides, and I'm going to subtract 15b to both sides. The 36 cancels on the left, the 15b cancels on the right. 2b minus 15b is going to give me 13b equals negative 2 plus 36. That's going to give me 26. Actually, I wrote that down wrong. I needed to distribute the 5 to the 2, so this should be negative 10. So when we add 36, then we get 26. So now what I'm going to do is I'm going to divide 13 to both sides. 26 divided by 13 is going to give me b equals 2. The next one, B, we have half, parenthesis 12n minus 4 equals 14 minus 10n. I'm going to distribute the half to 12n into the negative 4. Half of 12n is going to give me 6n, 6n minus 2 equals 14 minus 10n. Again, we want to get the variable on one side, the numbers by themselves on the other. So what I'm going to do here is I'm going to subtract 6n from the left, and I'll subtract 6n to the right. On the left, the 6n cancels. I'm going to now subtract 14 to both sides. Negative 2 and negative 14 is going to give me negative 16 equals negative 16n. I'll divide both sides by negative 16. And n equals positive 1, and that'll be my answer. Last set of examples here, it says solve the equation below. And here you'll notice that we're going to determine whether these equations are an identity or a no solution, similar to what we saw in the first slide. So A, we have 4 parenthesis x minus 5 equals 4x minus 20. Again, we'll distribute 4 times the x and 4 times negative 5. 4 times x, 4x. Minus 20 equals 4x minus 20. Notice they equal the same on the left and the right side. So technically, if you solve this, if you subtracted a 4x to both sides and added a 20 to both sides, it would give you a 0 equals 0, which that we call as an identity. And that would be your answer for A. For B here, we have 3x minus 9 equals 3x plus 10. Notice if we subtracted 3x to both sides, the 3x cancels on both sides. So what you're left with is negative 9 equals 10. Does negative 9 equal 10? It does not. So we say negative 9 does not equal 10. So we would say this is a no solution right here. And that'll be your answer. That is it for this section, and we'll practice some bookwork in class.